The goal of this experiment is to oxidize an alcohol to a ketone via Pinacol rearrangement. The ketone will then be transformed into its corresponding semicarbazone. Before starting any experiment, proper safety equipment such as safe lab attire, goggles, and gloves are mandatory and must be worn at all times. In a round bottom flask, a boiling stone was added along with the alcohol. Using a graduated cylinder, 6 molar sulfuric acid was carefully added to the flask. The flask was then clamped to a ring stand and the simple distillation apparatus was set up. The receiving flask was put on ice to prevent the product from evaporating. Once assembled, the heating mantle was turned on and the product water azeotrope is distilled over. Once the distillate is collected, the round bottom flask is removed from the apparatus and transferred to a separatory funnel. Due to the product being able to co-distill with water, they are allowed to separate. The layers are then separated and the aqueous layer is transferred back into the separatory funnel. The aqueous layer is then thrown back into the separatory funnel and extracted with DCM. The separatory funnel is then shaken and with intermittent venting. The layers are then allowed to settle and the organic layer, which is on the bottom, is taken. The aqueous layer is then extracted once more, and all organic layers are combined. Once done, the aqueous layer is then removed from the separatory funnel and put to the side. The organic layer is then taken and placed back into the separatory funnel. Some acid could have possibly distilled over, and so the product needs to be washed with base to remove any residual acid. The organic layer is then washed with a sodium bicarbonate solution. The separatory funnel is then shaken with frequent intermittent venting. Note that acid and bicarbonate produces lots of excess gas, so venting is very important. The layers are allowed to separate, and the organic layer, the bottom layer, is then taken. The organic layer is then dried with sodium sulfate until there is no longer any new clumping. The dried solution is then decanted into a new container to remove the sodium sulfate clumps. The solvent was then gently evaporated into in a heating mantle. The pure product was then used in the next part of the experiment. The next part of the experiment is a semicarbazone synthesis. In a test tube, semicarbazide hydrochloride and sodium acetate were added and dissolved in water. Using a pipette, a small amount of the ketone was added. The test tube was then capped and mixed. Once the contents were mixed, the test tube was placed in a hot water bath. The heat was then turned off and the test tube and water bath were allowed to cool to room temperature. Once cooled, the test tube was placed on ice and the precipitate was vacuum filtered. The crude semicarbazone was then recrystallized in the minimum amount of hot ethanol. Once the semicarbazone dissolved in boiling ethanol, the solution was then allowed to cool to room temperature. Once it reached room temperature, it was then placed on ice where crystallization was induced. The crystals were then vacuum filtered and dried. The melting point of the recrystallized semicarbazone was measured by placing it in a melting point capillary and into the melting point apparatus. The temperature was recorded when the sample began to melt to when it fully melted. This was then compared to the literature value. An IR spectrum of the starting alcohol was taken for reference. Make sure to clean the apparatus between samples. An IR spectrum of the ketone was also taken to compare to the alcohol. You should be able to analyze the success of the reaction from IR to the ketone, the melting point of the semicarbazone. Not shown in this lab are iodoform and can tests.